All right, let me now turn to the second topic that we want to demonstrate, and this is about Edge Cloud. Again, as I said at the beginning of my presentation, Edge Cloud is becoming a reality. It's actually nothing new, right? Remember Court Central Offices redesigned as a data center. Remember Mac multi-access edge computing. It's all the same. It's a new term for the same thing. It's about distributing compute throughout a telco infrastructure to create a much more agile environment, to have the ability to create services in the locations where you need them at the time you need them. Is it happening? I think it is happening. Actually, 5G is a big driver. We're building big 5G networks right now in North America and in APAC. They're a bit ahead of Europe, as you know. And for sure, like the big guys in North America are putting the infrastructure in place to do that, right? In a lot of those CO locations where they have their Cloud RAN, BBU or hotel BBU sites, they are putting compute already there into the infrastructure just to be sure that they can support those low latency services. So the result of that is, of course, a very, I think, powerful environment, but a very complex environment as well. So we basically have to become better at managing this complexity. There's two things that will be needed. First of all, there is the orchestration of virtualized networking functions, lifecycle managing them. I mean, installing them, removing them, scaling them. I think all of that has been pretty much, I think, figured out. That's fairly mature right now. The thing that has been missing so far is the networking part of that, or it hasn't been getting the attention that it should be getting. And even for us, right, the initial deployments we've done of telco cloud environments, we've basically looked at the cloud part and the telco part as separate, isolated worlds, right? We're using data center technologies in the cloud part. We're using VXLAN overlays, data center SDN controllers, all that good stuff. And then in the WAN, of course, we're using MPLS and segment routing and then VPN services on top of that. And us being good engineers, of course, we make it work. We stitch it all together, right? We create a data center gateway that does protocol translation and so forth. So it works. Problem is it's really complex, in all honesty. It's hard to automate. You don't have end-to-end path control. You don't have end-to-end SLA guarantees. So a better approach is needed, right? We need to treat those two domains as actually one single integrated domain. And that's why we brought the technology experience we had with SROS, Nuage, and NSP together, and we built a new solution. We talked about it last year. It's called NF-IX, Network Function Interconnect. We're going to demonstrate it here today on stage. It's a very powerful solution because it solves this problem. NF-IX is about taking a wide area networking technology, which is segment routing MPLS. I think that's the most promising technology. And we're extending that into the telco cloud environment all the way to the leaf, all the way to the point where virtualized networking functions attach to the network. That means a virtual leaf, like in the hypervisor, or a physical leaf, some Tor. And there might be segments there that you're doing segment routing MPLS over UDP IP because it might be an IP-only fabric. But in the end, the important thing is that you're getting end-to-end segment routing connectivity, which means it's uniform, it's much more simple, you get end-to-end path control, and you can drive end-to-end SLA guarantees. And the whole automation of this comes from the fact that we are basically going to run EVPNs on top of that to create slices. Network slicing, as you know, is a very important topic in 5G. Well, we believe EVPN is probably the most promising technology to create those slices. We introduced a new component called SRiC. It's a component of NSP that will listen to those EVPN BGP updates. And from those, whenever a VNF gets created, it will learn the connectivity requirements. It will also learn the SLA requirements for talking to that VNF. Those are represented by an abstract policy color representation. And then SRiC will automatically establish the required connectivity. It will translate that SLA requirement into a specific segment routing path to be taken through the network, and then push that through this, the systems using, for instance, BGP SRT policy or some other means. So very powerful solution. We believe this solves the problem of automating connectivity in a hybrid telco cloud environment. Ultimately, with this, You can create a virtualized networking function at a stadium because there is an event there, and we will automatically create all the connectivity that is needed end-to-end with guaranteed SLAs without human intervention. That's the ultimate goal. Now again, we can talk about this for hours, but much more powerful is to show you how this works. So we have a second demo here, which is about using NF-IX in the main context for which it was designed, which was 5G transport, and specifically supporting slicing in 5G transport. So we'll see a demo here of a service provider creating two slices, one slice for extreme mobile broadband services, another slice for ultra-reliable low-latency services. They have different edges through the network, and we will show you how you automate that connectivity. So for this second demo, I'd like to welcome on stage Anand Raj.
Hi, everyone. So for this, we're going to show you a three-phased automation approach. The first phase is discovery, the second phase is initialization, and the magic of automation actually happens in the third phase. So the first phase is the discovery phase, right? Well, it's discovery because you have to realize your topology elements on which you need to create your slices. So that's why the SRiC controller here discovers the wide area network topology, the mobile backhaul aggregation domains, the data center domains, and also interfaces with northbound applications, orchestrators, controllers to define your slice templates as well. So the way we do that is the SRiC peers using IGP and BGP for the WAN elements. And for our data center domains, we actually peer with a nuage controller in a hierarchical manner just to get what we need to get. Okay? And the slice definitions are programmed from the northbound application using APIs. So here's the topology that we discovered. And you can see there's a bunch of ISIS domains that are being highlighted right now. They constitute your mobile backhaul and your WAN domains. Now, if you focus on the left and the right of the topology, you'll see there's some highlighted data center elements that are discovered from the WSD. Now, the key thing to note here is that the connectivity is abstract. So what you have is dotted line connectivity, because we don't really need to understand the full leaf and spine architecture. We just need to understand where the leaf endpoints are. And it's exactly what we modeled in the NSP on the SRiC. And that helps us scale a lot of the discovery of the data center elements. It makes it much more agile as well. The last thing is programming the slice templates. Rudy mentioned two slices. There's two slices there. There's the enhanced mobile broadband slice. It's got a color reference, a TE policy, and same with the ultra-reliable low-latency slice. It's got a color and a TE policy articulating what needs to be created. Okay, so this pretty much concludes the discovery phase. And coming up, we have the service initialization phase. So what we do here is the SRiC discovers the service templates on the various devices. On the VNFs, it's service templates. On the PNFs, we have the service models. And the idea here is that you want to be able to create slice-specific or service-specific templates, specific to the 5G slice, and drive it back into the nodes. So for the PNF, this is done through netconf using a model-driven manner. And for the WSD, we use our APIs, again, through nuage. Okay? So this step does not actually create the slice. It sets this environment for the slice to be created. So doing this in NSP is really simple, right? All you need here is to specify the template, the name of the template, really, the type of service, okay? And then only thing you need to do is specify the endpoints on which you need to initialize the slice. So in this case, I've actually put the slice reference there. I'm now going to pick up my endpoint, which is the PNF endpoint on one side. And I'm going to pick up the DC network on which I need to instantiate the VNF. I'm not picking a DC endpoint here. Okay? And once I hit a deploy, the configurations are deployed. And that's it. This is done initially. It's not done every time I want to instantiate a slice. So you can see from the logs, configurations are deployed. Okay? And let's see what we've deployed actually. So on our VSD, we can see that we've automatically created an L3 template. Okay? And there's no virtual machines created yet. And if you go on our PNF device, you can see there's a VPLS configuration downloaded automatically as well. Again, all of this is done through SRiC in an automated approach. Right? So that concludes that phase. Now this is where the magic happens. This is the automation phase. The way we go about this here is we only create the slice when you onboard a virtual machine. So for two slices, we're going to onboard a virtual machine in the data center that's central to the west of us, which is the MBB VNF. And to the data center that's close to the PNF, we're going to instantiate the URLLC VNF. So the magic happens because when the virtual machine gets onboarded, the nuage controller generates an EVPN route. Using the attributes in the EVPN route, the SRiC is able to instantiate the slice. Okay? So the following demo will actually show that in its entirety. So I have a CLI, or a script router, to onboard a virtual machine. And you can see on the Nuage VSD, we have virtual machine, we have vport. There's a bunch of logs that are shown, and we'll go to the logs just to show the process. On the SRIC, we can see there's an endpoint received. It's an EVPN endpoint. Looking at it closely, there's an IP address associated to that. There's a color, and there's a slice reference along with raw targets. Okay? This drives the creation automatically of the SRT policy that Rudy was mentioning. So here we have actually a full SRT policy. There's the one that's driven to the source. It's hard to read. There's 3-hop label stack here, and the second hop is actually a binding SID. So we actually drive 2 SRT policies. We do some label compression as well. The path is realized as a 6-hop label path, but in reality we have 2 SRT instructions that are driven to different parts of the network there. So let's see the process in entirety, right? Starting from the VM onboarding, what you see is an EVPN route that gets generated by the Nuage controller. The NSP sitting on top of it intercepts that, looks at key characteristics. It looks at a color community. It looks at a route target. This is critical information. This is what the SRIC needs to then create the right slicing. And we deliver that to SRT policy, associating that to the right service template instance we deployed. So those statements there tell you that the SRT policy is created. And because we have to go all the way to the central data center, we don't have that many label hops, we have to compress it. So that's why we drive 2 SRT instructions. One's the binding SID, and one is the actual source instruction. So this is now repeated again for the next slice, which is URL LLC slice. Right? So the same thing happens here. We create the virtual machine. Actually, before I get there, sorry, this is the SR policy on the PNF device. So as we drove to the VSD, we are also showing the SR policy on the router itself, and there's a color associated with the 3-hop label stack. So we do the same thing for the next slice, which is URL LLC slice. We onboard a virtual machine, and as you can see, there's a virtual machine created, there's a vport created. Once again, we get an EVPN route. Okay? Using the characteristics of the EVPN route, again, the route target and the slice, we then create the right SRT policy. So there, once again, we show you associated with that particular template, there's a EVPN endpoint. And going to the logs again, we see with that endpoint, you have, again, the right target community and the color. So the color in this case is the URLC color, which is 1001. I'm sure no one can read this, but it's there, trust me. And then, based on that, again, we generate the SRT policy. Now, because this data center is closer to us, we don't really need to use any kind of label compression. Okay? It's just a 2-hop label stack, so it's delivered as a single SRT policy. Okay? So this concludes the automation part of it. Again, there's many more interesting use cases. Please stop by the booth, and I'll be happy to show them to you. Okay? And last thing is, again, the SR policy is delivered on the node as well. Okay? Thank you all.
Well done. All right. Thanks, Anand. Impressive to see NF-IX in action. It's more than slideware, as you can see. I think it's much more powerful to actually see it in action. And this is ready for prime time, so we're absolutely very, very happy with that.